You think gravity is a force pulling objects together, apples fall, planets orbit, masses attract. But Leonard Susskind says gravity isn't a force at all. It's not even real in the way you think. Gravity is geometry, it's entropy, it's information, it's emergent from quantum entanglement. And the truth about what gravity actually is will completely destroy your understanding of forces, space-time, and reality itself. Drop an apple. It falls. You say gravity pulled it down. Newton said masses attract with force proportional to their masses and inversely proportional to distance squared. Simple, clear, wrong. Einstein showed gravity is not a force. It's curved spacetime. Mass warps geometry. Objects follow geodesics in curved space. The apple falls because Earth's mass curves spacetime. The straightest possible path in that curved geometry goes downward. This was revolutionary, but Leonard Susskind says even Einstein didn't go far enough. Gravity is not just curved space-time, it's something far stranger, more fundamental, and less real than you can imagine. Gravity might be emergent, not fundamental. It arises from deeper physics, from quantum entanglement, from information theory, from thermodynamics. Gravity is not woven into the fabric of reality. Gravity is what happens when you don't look closely enough at reality's true fabric. Let me show you what Susskind means. Start with Einstein's breakthrough, general relativity. The core idea is elegantly simple. Space-time is not fixed background. It's dynamic, curved by matter and energy. The Einstein field equations relate space-time curvature to energy momentum. More precisely, the Einstein tensor equals 8 pi g over c to the fourth times the stress-energy tensor. Geometry equals energy. Matter tells space-time how to curve. Space-time tells matter how to move. This reciprocal relationship replaces Newton's force law. No force needed, just geometry. A planet orbiting a star is not being pulled. It's following a geodesic, the straightest possible path through curved space-time, like airplane flying great circle route on Earth's curved surface. Looks curved from outside, but it's the straightest path on the curved manifold. This explains everything Newton's gravity explains, plus more. Precession of Mercury's orbit, gravitational lensing, gravitational waves, black holes, all fall naturally from Einstein's equations. But there's a problem. Quantum mechanics. General relativity is classical theory, smooth, deterministic, continuous. Quantum mechanics is discrete, probabilistic, granular. These frameworks are incompatible at fundamental level. When you try to quantize gravity, make it quantum mechanical, everything breaks. Infinities appear, non-renormalizable. The math explodes. Standard techniques fail. This suggests gravity is different from other forces. Electromagnetism quantizes cleanly. Weak force, strong force, all have beautiful quantum descriptions. Standard model works perfectly, but gravity resists. For decades, physicists assumed we just haven't found the right approach. String theory, loop quantum gravity, various attempts, progress, but no final answer. Susskind proposes radical alternative. Maybe gravity can't be quantized because it's not fundamental. Maybe it's emergent, like temperature, like pressure. Macroscopic phenomena arising from microscopic dynamics. Temperature isn't fundamental. It's average kinetic energy of molecules. You can't quantize temperature. It's already emergent from quantized particles. Maybe gravity is similar, emergent from quantum degrees of freedom, not a fundamental force requiring quantization, but collective effect of deeper quantum physics. This idea comes from black hole thermodynamics, Susskind's specialty. Black holes have temperature, Hawking radiation, they have entropy. Bekenstein-Hawking entropy proportional to horizon area. But thermodynamics is emergent. Statistical mechanics of many particles. If black holes have thermodynamics, they must have statistical mechanics. Microscopic quantum states underlying the macroscopic gravitational behavior. The entropy formula is S equals KB times A over 4LP squared. Entropy equals Boltzmann constant times area over 4 Planck lengths squared. This says black hole entropy is proportional to horizon area, not volume. This is weird. Normal thermodynamic systems have entropy proportional to volume. More space, more states, more entropy. But black holes are different. Maximum entropy determined by surface area. This suggests information is fundamentally stored on surfaces, not in volumes. Susskind developed this into the holographic principle. The maximum information content of any region is determined by its boundary area, not its volume. This is profound. It means the 3D universe we experience might be holographic projection of 2D information. Gravity in 3D emerges from quantum field theory on 2D boundary. The AD-CFT correspondence proves this mathematically for certain spacetimes. Anti-de Sitter space in 5 dimensions is exactly equivalent to conformal field theory on 4-dimensional boundary. Gravity emerges from quantum mechanics, not fundamental. Derived. Susskind emphasizes this changes everything. If gravity is emergent, it's not a force to be quantized. It's a collective phenomenon arising from quantum entanglement. Think of it like this. Sound waves in solid are collective vibrations of atoms. You don't need to quantize sound separately. Sound emerges from quantized atomic motion. Phonons are quasi-particles, not fundamental particles. Similarly, gravitons might be quasi-particles, collective excitations of deeper quantum degrees of freedom, not fundamental, emergent. This explains why quantizing gravity is so hard. You're trying to quantize something that's already emergent from quantum mechanics, like trying to quantize temperature. Category error. Now let's go deeper. Eric Verlinde proposed gravity is entropic force, not fundamental interaction, but tendency toward maximum entropy. The argument goes like this. Information theory says systems tend toward maximum entropy. Space-time has entropy. Gravitational attraction is tendency to increase total entropy. When mass moves, it changes entropy distribution. Gravity emerges as statistical tendency toward configurations with higher entropy, not force in traditional sense. Entropic pressure. Verlinde derived Newton's law of gravitation from thermodynamics. F equals ma emerges from entropy gradients. No force required, just information theory. This is controversial. Many physicists skeptical. But Susskind sees merit. If holographic principle is correct, if information is on boundaries, then gravity naturally connects to entropy, to information. The connection between gravity and thermodynamics runs deep. Black holes have temperature. Event horizons have entropy. The laws of black hole mechanics perfectly parallel thermodynamics laws. First law, energy conservation. Change in mass equals temperature times change in entropy plus work terms, exactly like thermodynamic first law. Second law, entropy never decreases. Horizon area never decreases. Hawking's area theorem. Second law of thermodynamics. Third law, you can't reach absolute zero. You can't reach zero surface gravity. Extremal black holes are limit, never achieved. The parallels are too perfect to be coincidence. They suggest gravity is thermodynamics. Space-time geometry is statistical mechanics. Curvature is entropy distribution. Susskind has worked extensively on this. The ER-EPR proposal. Einstein-Rosen bridges equal Einstein-Podolsky-Rosen entanglement. Wormholes equal quantum entanglement. If this is true, space-time connectivity comes from entanglement. Geometry emerges from quantum correlations. Gravity is how entanglement manifests at macroscopic scales. Two entangled particles are connected by microscopic wormhole. Einstein-Rosen bridge. Quantum entanglement creates geometric connection. Space-time emerges from entanglement structure. Scale this up. Huge numbers of entangled quantum degrees of freedom create macroscopic space-time. Gravity is collective effect of entanglement patterns. Curvature reflects entanglement density. This is speculative, cutting-edge research. But the mathematics is compelling. ER-EPR connects quantum mechanics to general relativity, suggests they're different descriptions of same underlying reality. Now consider what this means. If gravity is emergent, what's fundamental? What underlies it? Quantum information? Entanglement? Hilbert space dynamics? The real fabric of reality is quantum states evolving unitarily. Space-time and gravity emerge from this at macroscopic scales. At Planck's scale, space-time might not exist. No geometry, no curvature, just quantum information. Raw qubits, entanglement patterns, abstract mathematical structure. Only when you coarse-grain average over many quantum degrees of freedom does space-time emerge. Geometry appears, gravity manifests, but it's not fundamental. It's approximate, emergent. This is like asking what water is made of at small scales. At human scales, water is continuous fluid. Deeper, its molecules. Deeper still, atoms. Deeper, quantum fields. Similarly, space-time at human scales appears continuous. Smooth geometry, but at Planck's scale, it dissolves into quantum foam. Fluctuating quantum information, no definite geometry. Gravity is how this quantum information appears when viewed at large scales, through low-resolution lens, when you can't see individual quantum degrees of freedom. Susskind notes, this explains why quantum gravity is hard. You're trying to find quantum theory of something that emerges from quantum theory. The question is backwards. Don't quantize gravity. Recognize gravity as emergent from quantum mechanics. Focus on underlying quantum degrees of freedom, how they're organized, how entanglement creates geometry. This is modern approach. ADS, CFT, tensor networks, quantum error correction codes. These frameworks show how space-time emerges from quantum information, how geometry is entropy, how gravity is entanglement. Let's explore the implications of gravity being emergent and not fundamental. First, dark matter and dark energy. We observe gravitational effects that don't match visible matter. Galaxies rotate too fast. Universe expands too quickly. We postulate dark matter and dark energy to explain this. But if gravity is emergent, maybe modifications appear at certain scales, not from new matter, from how emergence works. Emergent phenomena can have effective descriptions that differ from fundamental ones. Modified Newtonian dynamics, MOND, proposes gravity behaves differently at low accelerations. Not new force law, just different regime where emergence works differently. Verlinde's entropic gravity predicts MOND-like effects naturally. At low accelerations, entropy gradients behave differently. Apparent dark matter emerges from thermodynamics, not actual particles. This is controversial. Most physicists favor particle dark matter, but entropic view is intriguing alternative. If gravity is emergent, dark matter might be too. Both artifacts of how we describe emergent phenomenon. Dark energy is even stranger. Vacuum energy, cosmological constant, makes universe accelerate. But calculated value is 120 orders of magnitude wrong. Worst prediction in physics. If gravity is emergent, maybe cosmological constant isn't fundamental parameter. Maybe it's emergent from quantum vacuum structure, from entanglement patterns at cosmic scales. Susskind's work on landscape and eternal inflation suggests cosmological constant varies across multiverse. Our value is anthropically selected. We exist in region where it's small enough for structure formation. But deeper question, why does vacuum energy gravitate at all? In quantum field theory, vacuum has huge energy, but this should curve space-time enormously. It doesn't. Why? Maybe because gravity is emergent. Vacuum energy is fundamental, but it doesn't couple to emergent gravity the same way matter does. Different emergence mechanism, explaining the tiny cosmological constant naturally. This is speculative. But emergent gravity offers new perspectives on these deep problems. Not necessarily solutions, but different ways to think about them. Second implication, quantum information in black holes. The information paradox. Hawking said black holes destroy information, violates quantum mechanics, unitarity. Susskind fought Hawking on this, argued information must be preserved, eventually proved right through holography and string theory. But how? Where does information go? If black hole evaporates, where did the information of infalling matter go? Holographic principle answers this. Information never goes inside. It's encoded on event horizon. In microscopic quantum degrees of freedom of horizon, as black hole evaporates, Hawking radiation carries information out, scrambled, encrypted, but preserved. The radiation is not thermal. It contains all the information in subtle correlations. This only makes sense if gravity is emergent. If horizon is made of quantum degrees of freedom, if area equals entropy equals number of qubits, then information storage on horizon is natural. The horizon is not smooth classical surface. It's quantum system with huge number of microstates. Area in Planck units equals number of bits. Maximum information density. Gravity emerges from collective behavior of these bits. Curvature reflects their entropy. The smooth classical black hole is coarse-grained description of quantum horizon. Susskind's black hole complementarity explains how infalling and outside observers see different physics. Both descriptions valid. Both describe same quantum state from different perspectives. This is possible because gravity is emergent. Different observers at different scales see different effective descriptions, both correct in their regime, neither fundamental. Third implication, the measurement problem. Quantum mechanics has this unsolved problem. Superposition until measurement, then collapse. But what causes collapse? What counts as measurement? If space-time is emergent from entanglement, measurement might be tied to geometry. Decoherence creates classical space-time. Superposition exists in quantum information layer. Collapse is emergence of definite geometry. This is Roger Penrose's idea. Gravity causes wave function collapse. When superposition becomes gravitationally significant, it collapses. Objective collapse triggered by gravitational effects. But if gravity is emergent, this gets subtle. Gravity doesn't cause collapse. Emergence of gravity is collapse. When quantum information organizes into classical geometry, that's when definite outcome appears. Measurement creates classical spacetime. Unmeasured quantum states exist in pre-geometric quantum information layer. Measurement is transition from quantum to emergent geometric description. This is highly speculative, but it suggests measurement problem and quantum gravity are related, both about boundary between quantum and classical, between fundamental and emergent. Susskind explores this through tensor networks. Quantum states organize into network structure. Geometry emerges from network. Entanglement pattern determines space-time structure. Measurement might be coarse graining operation on tensor network, losing information about microscopic structure, keeping only macroscopic emergent geometry. This is collapse. Fourth implication, time. If space-time is emergent, time is emergent too. What's fundamental? Quantum evolution. Unitary operators, Hamiltonian dynamics, but these still use time parameter. Or do they? Wheeler-DeWitt equation describes universe quantum mechanically. It has no time. Wave function of universe is timeless. Time emerges from correlations, internal clocks. Entanglement between subsystems creates apparent time evolution, but fundamentally, the quantum state is static, eternal. This connects to block universe. Time is emergent geometric feature, not fundamental flow. Gravity is emergent geometry. Time is aspect of that emergence. Susskind's work on AD-CFT shows this explicitly. Boundary theory has time. Bulk gravity emerges with time as geometric dimension. Time is part of emergent space-time description. This means temporal causality is emergent too. Causal structure is geometric. Light cones emerge with space-time. But fundamental quantum theory might not have causality in usual sense. Quantum entanglement is instantaneous, non-local, violates naive causality. But it's fundamental. Gravity and causality emerge from entanglement patterns. They inherit approximate locality. At Planck scale, causality breaks down. Because space-time breaks down, only quantum correlations remain. No before or after, no here or there, just entanglement structure. Fifth implication, the multiverse. If gravity is emergent, different entanglement patterns create different geometries. Different spacetimes, different universes. The landscape of string theory. 10,500 possible vacuum states. Each creates different physics, different constants, different dimensions. Eternal inflation explores this landscape. Different regions settle into different vacua, creating pocket universes. Multiverse. But if space-time is emergent, the multiverse is not spatial, not different places, different entanglement structures, different ways quantum information organizes. Our universe is one organization pattern. Other universes are other patterns, all existing in abstract Hilbert space, not in geometric space. Space is emergent within each pattern. This makes multiverse more abstract, less physical, more mathematical, but also more fundamental. Geometry is approximate. Entanglement is real. Susskind's anthropic arguments become clearer. We observe physics that permits observers because only certain entanglement patterns create observers. Selection effect in Hilbert space, not spatial location. Sixth implication, the nature of forces. If gravity is emergent, what about other forces? Are they fundamental or emergent too? Electromagnetism is well quantized. QED works perfectly, suggests it's fundamental, but maybe it's emergent from deeper structure too. Grand unification theories suggest all forces unify at high energy. Electromagnetic, weak, strong forces merge into one. Maybe that unified force is fundamental. Low energy forces are emergent. Or maybe all forces are emergent. Only quantum information is fundamental. Forces are how information constraints manifest at macroscopic scales. This is speculative limit. But if gravity can be emergent, why not everything else? Maybe all of physics is emergent from pure quantum information theory. The laws of physics would be information processing protocols. Conservation laws would be information conservation. Forces would be information flow. Particles would be information patterns. This is it from BIT. John Wheeler's vision. Information is fundamental. Physics emerges from information theory. Gravity is just one emergent aspect. Susskind is sympathetic to this view. His work on holography, black holes, entanglement all point toward information as foundation, geometry as emergent, physics as quantum computation. Seventh implication, experiments. Can we test if gravity is emergent? Hard. Quantum gravity effects appear at Planck's scale, 10^35 meters. Unreachable by current technology, but emergent phenomena sometimes have signatures at accessible scales. Phonons in solids can be detected even though they're emergent. Maybe gravitons have similar signatures, or deviations from general relativity at certain scales. If emergence process has characteristic scales, effects might appear where emergence transitions. Verlinde's entropic gravity predicts Mond-like behavior. Testable. Observations favor either dark matter or modified gravity. Distinguishing is hard, but possible. Holographic noise. If space-time is pixelated at Planck scale, might show up as noise in gravitational wave detectors. GEO 600 and LIGO might see this. No detection yet, but search continues. Quantum entanglement experiments might indirectly test ER-EPR. If entanglement creates geometry, strong entanglement might create measurable space-time effects. Speculative but conceivable. Susskind emphasizes most direct tests require quantum gravity regime. Black hole mergers, early universe, Planck-scale physics, difficult. But gravitational wave astronomy and cosmology provide new windows. Eighth implication, philosophical. If gravity isn't fundamental, what is? Where does emergence stop? Is anything fundamental? Maybe turtles all the way down. Each layer emerges from deeper layer. Infinite regress, no bottom. Or maybe quantum information is fundamental. Hilbert space, unitary evolution, entanglement. These are the bedrock. Everything else emerges. Susskind leans toward latter. Quantum mechanics is fundamental. Everything else is emergent. Space-time, forces, particles, fields, all derived from quantum information. This is mathematical universe hypothesis. Reality is mathematical structure. Quantum mechanics is that structure. Everything physical is representation of abstract mathematics. Gravity reveals this. Being emergent, it shows that physical concepts like force and geometry are approximate. Mathematical concepts like information and entanglement are real. Ninth implication, consciousness. If physics is emergent from information, what about consciousness? Is it emergent too? Integrated information theory suggests consciousness is information integrated in specific way. Certain information structures are conscious, others are not. If this is true and if information is fundamental, consciousness might be as fundamental as gravity is emergent. Different organizational levels of same information substrate. Gravity emerges from quantum entanglement. Consciousness emerges from neural information processing. Both are real, both are emergent, both are information patterns. Susskind doesn't work on consciousness, but his information-based view of physics is compatible with information-based views of consciousness. Both point to information as fundamental currency of reality. 10th implication, meaning. If gravity is illusion, emergent, not fundamental, does that make it less real? No. Susskind emphasizes emergence doesn't mean unreality. Temperature is emergent, still real, still matters, still affects things. Gravity is same, emergent but real at its scale. Apples fall, planets orbit, black holes exist, all real phenomena, all correctly described by general relativity at appropriate scales. Knowing gravity is emergent doesn't diminish it. It deepens understanding, shows how it connects to quantum mechanics, to information, to entropy. Reality has layers. Each layer is real in its domain. Gravity is real macroscopically. Quantum entanglement is real microscopically. Both are aspects of deeper truth. The hidden truth about gravity is not that it's fake, it's that it's emergent, arising from quantum information, from entanglement patterns, from thermodynamics. This makes gravity more interesting, more connected to rest of physics, more comprehensible, not isolated force, but manifestation of information theory. Welcome to emergent gravity, where forces are collective phenomena, where space-time arises from quantum correlations, where geometry is entropy, where information is fundamental. Leonard Susskind has revealed this truth through decades of work. Holography, black holes, EPR, ADS, CFT, all pieces of puzzle. Gravity is not what you think. It's stranger, more beautiful, more fundamental in being less fundamental, emergent from the quantum realm. That's the hidden truth, and it changes everything.